Table. Go. When you are done filling it in, sketch a graph of it. I'll wait a few more seconds whilst you sketch your graph. I know I made it very difficult by starting with a fraction, but you can all handle it. It's one of the easier fractions to deal with. Okay, what are my four values of y? What's my first value of y? -3. My next value? -2. My next value? -1.5. And my last value? 0. How did you know that those were the numbers that go in there? Because, of course, you're right. How were you able to fill in this table of values? This is not a trick question. You take the x and you put it into the equation. Why? This is what's known as a pregnant pause. I've got 75 more minutes. These are x's. They are inputs, so I can put them everywhere I see an x. Once I have inputted those inputs, what do I get? Outputs. And those outputs are y. Everybody cool? Can I pick any number to go in this column? Yes. Can I pick any number to go in the y column? No. Because I can't figure out y until I know what x is. Because this question says y equals all this math that I do to x. Everybody okay with that? Okay. So in this case, this is my output, which means it's my range. This is my input, which means it's my domain. So if I were going to graph this, I would go to -2, -3. Oops, I should have gone lower there. -2, -3. 0, -2, and 4, 0. I'm skipping the half because it doesn't matter. And then I would draw the line, right? Everybody remembers that from 9th grade, yes? Okay. The only thing that is changing now is instead of y, we are going to use what is called function notation. And function notation is simply this. Fx. F is the function's name. To differentiate it from other functions that may or may not be in the same question. For example, if I needed to talk to Anthony, how would I get his attention? I would say his name. If I wanted to talk to Anthony, would I say, hey, Ethan? No. So this is naming the function. That means we are only going to deal with functions that have an F there. Any other letter can go there. So I could have G of X. I could have H of X. And all that means is I have 3 different sets of math that I'm going to do. Everybody understand? So we have right now, and that means the f of x becomes my output. What was my output before? Before, it was y. Now it's f of x. So this question here, we write now, because we're in grade 10, we are going to write it as f of x equals 1/2 x minus 2. Okay? That's the only thing that changes. It looks different, but it's just changing looks. So you can see right here, you have an x. Yes? Here you have an x. Everyone agree? From this table, where do I put these x's? Everywhere I see an x, yes? So in function notation, we would write this first line like this. The f of -2, x has become -2, equals 1/2. What is x now? -2 minus 2. So there is my input, because I'm inputting it into the function. It gives me my output of -1 minus 2, which is -3. Everybody got it? Now, if you think back, some of you will have had textbooks in about grade 5 or 6 that drew something like this. Did any of you ever see a construction like that in your textbook? The number falls in, then you add 2, then you multiply by 3, then you take away 4, and then you get an output. And it was called in those textbooks a function machine. And some of the textbooks had real pretty drawings, and it looked way better than this. Some of you remember seeing that. And then you never saw it again, did you? And here we are in the 10th grade talking about functions. Had Mrs. Bad Crumble taken one more second and gone past this, you could have learnt this 5 years ago, and then we could have done something with it. Okay? Everybody good? That's all it is. It's that thing you saw in grade 6 with the function machine. Now, I think on mine, I of course have to turn it off because it's not working. I believe I have a typo on my notes here, and your guys' is right. Do you have XX, 2, and -3, or do you guys have a J somewhere in there? You have X's? Oh, good, because there used to be a typo on this, and I wasn't sure which one I printed. So you already know how to do this. F of X is the name of this function. This tells me that I have inputs for function f. What are those 2 inputs? Those inputs are 2 and -3. So how do I go about finding the appropriate outputs? Well, I start with the f of 2. X has become 2, so what does this x become? 2 minus 7. What is 2 times 2? 4 minus 7, negative 3. Now, all of you know how to do that. We're going to take it one step further and ask you, if I were to graph this, what would the point on the graph be? 2, negative 3. Is everybody good? Yeah? Okay. What then is this one? It's the f of negative 3. So what do I put in instead of x everywhere in that function? Negative 3. What's the point from the graph? Negative 3, negative 13. Is everybody good? That's it. That's the entirety of the concept behind this lesson. Do you all understand that? So if I were to ask you what the f of lightning bolt is, what would you do? 2 lightning bolt minus 7. And could you go any further? You can't go any further, can you? Everybody cool? Okay. What if I gave you this? G of x equals x plus 1. Everybody good? And I tell you, no, I can't use x. Sorry, I'm a dink. Sorry, pardon me. G of n equals n plus 1. And I tell you I want the g of 7. Could you do that? What is it? 7 plus 1. Everybody good at that? Okay. Now I want the f of the g of 7. Can you figure that out? What is the g of 7? We just did that right here. What is it? What? 8. So the g of 7 is what? So I need to find the f of what? 8. And now I am switching functions back to f. What's the f function? 2x minus 7, which is 16 minus 7. I just gave it away, but all of you can subtract. 16 minus 7 equals 9. Do all of you understand that? How many times could I stack functions inside of each other? Is there any limit to it? No. What's the first one you have to find? The most central one. Okay? Could I give you this? The f of the g of the h of 4. Could you figure that out? Yes, as long as you knew what? What f of x was, what g of x was, and what h of x was. Where would you start, f, g, or h? H. And then you could do it, right? Because once you had the h of 4, where would you then put this answer? Into g. And once you had that, where would you put that answer? Into f. Can everybody do it? It's just substitution, right? It's all it is. Just got a new fancy looking name. Got it? Okay, let's turn the page over and let's do something with it. You will notice on this page, I have given you both blank space and a graph, right? That is because functions work in two places. Functions work algebraically, which is what we just did. You don't have to spell out algebraically, but they also work graphically. And you know functions work graphically because we've been doing that this unit, right? Draw the line, vertical line test, blah, blah, blah. You all know how to do that, right? So, I want to solve this, both algebraically and graphically. Does it matter which one you start with? Right now it does, because very few of you are able to look at that function and tell me what it looks like on a graph without what? What would you need to do to graph that right now? You could use a graphing calculator. What else could you do? You just did it on the previous page. You could use a table of values, right? Now that table of values is just inputs and outputs, isn't it? And what's function notation? Inputs and outputs, yeah? So I have g of x equals negative 2/3 x plus 1. And I need the g of 6, and I need the g of negative 3. Are those x or y values? Is that and that x or y values? They're x values. So I could put them on a graph, couldn't I? But I don't know where to put the y value yet, do I? Because I only have an input. So let's input it. That x has become a 6, so what does that x become? What is this answer? What is negative 2/3 times 6? I'm not going to tell you because all of you know how to multiply fractions. It is indeed 4, but it's negative 4, right? Okay. And what's negative 4 plus 1? Negative 3. So now, do I have a point on the graph? Yes. What is the x value of that point? 6. What is the y value? Negative 3. Well done, everyone. Now, what happens here? Same thing. What's x become? Negative 3. So what goes into the graph? Or what goes into the function? Negative 3 plus 1. What's negative 2/3 times negative 3? Pardon? Positive 2, absolutely right, because negative times a negative is a positive and the 3's cancel. Plus 1. What's 2 plus 1? 3. So what's the next point I have on the graph? Negative 3, 3. Everybody good? So now let's take this and let's go over to the graph. The first point I have is 6. 1, 2, 3, 4, 5, 6. Negative 3. 1, 2, 3. The second point is negative 3. 1, 2, 3. Positive 3. What do I get to do with those two dots? Connect them. Why? Why is this continuous data? Because why? Say it, Marin, because you're right. You can do it. I have faith. Yeah, we're using the same equation. And can I take any number and multiply it by 2/3 and then add 1 to it? Yes. So I will connect this line. Now I realize I'm making it slightly more difficult by insisting on putting fractions in. But does it change? No, of course not. Now, I said we're going to do stuff graphically, yes? So once I've drawn this line, now what do I know about every single point on this line? Does it have an X and a Y? Yes, even if they're in the middle, right? And what do I know about those X's and Y's? Where can I put any X that I find on this line? What do I know about this point right here? What are its coordinates? -3, 3. What do I know about that X? Where can I put it? Into the equation, right? Where can I put this X? Into the equation. So where could I put this X? Into the equation. Where could I put this X? Into the equation. And what will be my output? That Y. That Y. Does everybody understand? Okay. So using the information that you just remembered, using that information, can you do the next question either graphically or algebraically? Or both. If you were going to do it graphically, where would you go? On the x-axis or the y-axis for this? On the y-axis, did you say, Alma? I just didn't hear you. I'm not saying if you're right or wrong. Yes, you would go on the y-axis. Why? Because we're trying to find x. So I know the y. So I would go up to 7. 1, 2, 3, 4, 5, 6, 7. And then I would try to find the x. It's somewhere out here, isn't it? Does my graph get there? It will if I continue it. Am I allowed to continue the line? Why? Because it's continuous data. Okay? So I could find it by continuing the line and checking. Where this line crosses 7 is going to give me an x, isn't it? But since that line doesn't make it, can I be 100% sure? Not graphically, can I? Can I be 100% sure algebraically? Yes. I have g of x equals -2/3 x plus 1. Now, as Elma says, I'm trying to find x. So is this x allowed to change? Yes or no? No, it can't, because I don't know what x is, do I? But do I know what g of x is? What is it? So where could I put that 7? Does it go there, or does it go for the whole thing? It goes for the whole thing. Because if it was just going there, it would be x equals 7, wouldn't it? So what do I really have here? I have 7 equals -2/3 x plus 1. Is everyone okay with that? It's a subtle difference, right? Because I'm not looking for the g of 7. I'm looking for the x when I have 7. Okay? Do we all know how to solve that? We remember our grade 9 algebra? What am I going to do? I'm going to add 1 to both sides. 8 equals -2/3 x. I'm going to multiply both sides by 3. 16 equals -2x. And x equals -8. Everybody okay? Now let's check. does that work with our line? What is the point on the graph that this has given us? What's my x? -8. What's my y? 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Does my line go through there? Oh, jeez, what an idiot. Why do you guys let me go that far? Obviously, I am talking and I have made an idiotic error. Like when you're walking down the street and you fall. You did not mean to fall. You know how to walk. Grumph. So, it was 6 equals -2/3 x times 3, 18 equals -2x, x equals -9. Now, does everything else I say apply? So I go out to -1, 2, 3, 4, 5, 6, 7, 8, 9, and up to 1, 2, 3, 4, 5, 6, 7. And then I check with my straight line math tool, like you're a straight line math tool. And you can see that it goes through all of my other points. Okay? Everybody good? Nothing changes, right? It's just x and y with a new way of writing it. And the reason we do it is because if I want to put 4 or 5 lines on a graph and I only give you x's and y's, do you know which x's and y's go with which line? Do you? Like if I put a red line on this graph, does that red line have x's and y's? It does. And there's no way to tell which I'm talking about, is there? Because if I say, I want to put any coordinates on this graph, I don't know if I'm talking about the red line or the blue line. So that's why we use function notation. So I know which line I am dealing with. Everybody okay? All right. So let's do that. Now, I am all scared about doing algebra now because I screwed up earlier. Don't be like me. You be strong. Okay? I have a new function. It is m of x equals 4/3 x plus 2. What do I need to find? I need to find the m of 7. I need to find the m of 1. And I need to find the m of x equals 5. So, here, I'm looking for what? An x or a y value? Y. Here I'm looking for what? A y. Here I'm looking for what? An x. So all you do is substitute in appropriately. I have m of x. X has become 7. So what does that x become? 7. Do your math. Everybody okay? I'm a little more practiced at fractions. Does everybody understand what I did there? I purposefully just worked through it. What did I have to do to 2 to make this work? I had to make it 6/3, yes? 28 plus 6 is 34. Right? The other thing I could have done is I could have made this 9 1/3 plus 2 to get 11 1/3. Both of which work. Everybody good? I know you don't like dealing with fractions. That's why I'm doing this to you. I get double the math lesson out of it. You substitute in, and I get to make you practice your fractions. What's this one going to be? Four thirds times what? 1 plus 2. 4 thirds plus 2, which is 3 1/3. Now, yeah, no problem. Okay. That's 4 thirds plus 6 thirds is 10 thirds. 10 thirds is 1 1/3 or 3 1/3. Everybody cool? Okay. What is different with the green one? I'm trying to find x. So x has to stay x, doesn't it? So what do I have now? I have 5 equals 4 thirds x plus 2 because I'm looking for x. And then we just do algebra, yes? 2 comes over here. 3 equals 4 thirds x. Yes? How do I get rid of the 3? Multiply by 3, 9. 9 equals 4x. Now what? Divide by 4. Excuse me. So 2 1/4 equals x. Can everybody do this? Don't say you're having trouble with it because of the fractions. Don't let the computation get in the way. Do you get the concept? Could I have done this with just regular numbers? Of course I could have. That's what I did on the first page, right? When we had 2x plus 5. Just getting a little bonus for myself here. There's a reason I'm doing it, too. But you'll see that in 2 days. Is everybody good? Yeah? 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 Okay. You guys do the last one because that is the exact same as number 5. Except with different numbers. Duh. You can check up on the board when you're done, or as you are working through to make sure you are doing it right. Can everybody handle the algebra? You may need your calculator. That's fine. That's not what I'm asking you. Can everybody handle the algebra of function notation? Yes? Everyone is good?
On that one, wouldn't you add for? Yeah, it would be zero. Never mind. I copied it down wrong.
Okay. Everybody good? Everybody can do the algebra? Okay. If I show you one that's all easy, no fractions, I want you to try it in your head. Okay? See if you can do that in your head. Who thinks they have an answer? Don't say it out loud, Luke. I want to let a couple of other people get their answers. Then we'll go through it. You can see if you're right. Okay, Luke, where'd you start? G of 2. Okay, so what'd you do for that? Right there, yes? So what is that? So what goes here? 4. Where does that go? What's 2 times 4? Minus 1. So this is 7. Can everybody do it? Yeah? Okay. Does it matter if there's crazy decimals? No, you're just going to use your calculator. Does it matter if there's fractions? No, you're just going to either use what you know about fractions or use your calculator. Would it matter if there were squares or cubes? Would any of that matter? No, because you're just substituting. Is everyone okay? Everyone can do the algebra? On a scale of 1 to 10, you're all at least a 5? Okay. Now, I told you this goes, there's the algebra and there's the graphing. Turn the page over. Here we have graphing. Okay? The f of x is the black one. Mr. Myers, it's curvy, barf. Does it matter? No. You know what a curve looks like. You know there has to be a square in the equation somewhere, right? Okay. The blue one is the g of x. What do you know about every point along that black line? They all have an x and a y, yes? And that x and y, can the x's and y's along here, do they go into the f's or the g functions? For example, this point right here, would that go in for an f or for a g?
F.
An f, because it's on the f of x line. Okay? Everybody good? All right. So in this first question, I have the graph. There's 2 lines on it, so I have to give 2 different function names. One is f, one is g. I need the f of -3. So, is that an input or an output? It is an input, which means it is on which axis? X or Y axis? X. So I need to go to -3 on the X axis and find the Y that goes with which line? The curve or the straight? The curve. So I go out to -3 and I try to find my output. And it's right there. What is it? Equals -2. Is everybody good? Going once, going twice, going thrice. Okay. What's this one? Is that an input or an output? It's an input. So it's on the x-axis. So I go to 0 and I look for the output. On which line? The straight one this time, because this is a G. So I go up and I find it is right there. What is it? Equals 2. Is everybody good? Okay, you guys do C. What is the answer? -3. Yes? All right. Look at D. How is D different? You're trying to find X. So if you don't know X, you must know Y. What is Y here? 1. So here I have an output, which means it's on the Y-axis. So I go to where on the y-axis? 1, and I find the x value. Oh, it's already going through that. What is it? 0. So this x equals 0. Everybody good? Okay. What is it for E? That's an output, right? Which means I look on the y-axis at what spot? 3. And now I find where the line hits 3. Right there, correct? What's the x value? X equals -1. Everybody good? Yeah? Okay. You do the last one. You decide if it's input or output. Tell me what it is. Who's got an answer? What is the G of 4? -2. Does everybody think they have it? With the pictures too. Okay, I'm going to give you one that might fool you. So think about it. Everybody ready? Oh, I already did that one. It was supposed to be G of -2. Sorry, I was writing in blue. What's that? Four? Okay. Everyone is good? Now, what's this one? The f of x equals -2. Who has an answer for me? Elma. -1. Is Elma right? Is Elma completely right? Why not, Scarlett?
Because it's a curve, it's -1 and
It's a curve. There's two of them. Everybody see? Alma, you found the first one perfectly. You did everything right. But remember, the lines continue on, yes? So it is also -3. Is everybody good? Okay. That's the end of the unit. You did a whole unit in 4 days. Why? Because what did we really do that was new? We gave a new name to something you could already do, right? And you learned new names for X's and Y's, domain and range. Everybody cool? All right, now listen. I think your booklet ends, yes. So you guys have, now, if you are going to do any work out of your textbook this unit, I really recommend you have a look at function notation because you probably haven't seen it before. Have any of you seen that before? Okay, so that's kind of new. I really recommend you have a look at that. I have also given you a checklist because this is the first unit where we have equated pictures, graphs, with numbers, math. Okay? So it's kind of weird. So I gave you that checklist so you can check yourself on these topics because we're going to have a test on it next week. Okay? We're going to have that test on Tuesday. I'm going to give you, right now, 20 odd minutes to look at this. I'm also going to print you a review. Okay? That review, I expect you to do over the weekend. You don't need to do all of this because I trust you. But you need to do enough of it to make sure you know what you're doing. Okay? Okay.